Now in section 9.3, we're going to talk about both cylinders and cones in the same section because we've already learned about prisms, which have two bases but a polygon in each base, and we've learned about pyramids, which have just one base, that's a polygon. Well, cylinders and cones look a lot like prisms and pyramids, except that their bases are always circles. So the bases are circles. In a cylinder, there are two bases that are on parallel planes, and for a cone, there's just one base, and it goes up to a vertex point. All right, and we'll learn about surface area and volume for cylinders and cones as well. So let's talk about cylinders. Cylinders have parallel bases and parallel planes, and their bases are always circles. So, taking what we already know about prisms, first of all, you can have a right cylinder, or you can have an oblique cylinder, depending on if it's straight up and down. These are quick drawings, or if it, goes on a slant. If the angle is not a 90-degree angle, it would be considered an oblique cylinder. And an important piece of information would be the altitude of the cylinder. So that's also called the height of the cylinder. That is the distance between the bases. The distance between the bases. And the bases are congruent circles. So they have the same radius. So here's an example of a right circular cylinder. You really don't even have to say circular cylinder. We're assuming that the base is going to be a circle. And here they're not even showing the parallel planes. They're assuming that you know that the planes are parallel now. And so the height would be from the center of one circle, the distance from the center of one circle to the center of the circle on the parallel plane. And this line segment, not only being the altitude of the circle, is also called the axis of the cylinder. Okay. So when we're talking about surface area, let's remember surface area of a polygon. Surface area of a prism. So the polygon is the base. The surface area of a prism, where the polygon is the base. The lateral surface area is equal to the height times the perimeter of the base. That's the perimeter of the perimeter of the square or the rectangle or the triangle or the pentagon, whatever the base is. For a cylinder, our base is a circle. So we don't have perimeter of a circle, but we do have circumference of a circle. So the lateral surface area is going to be the height. We're not going to say perimeter, we're going to say circumference. Circumference. It's really the distance around the outside of the circle. This is the height times the distance around the outside of the polygon. This is the height times the distance around the outside of the circle. And so what is our lateral surface area? The height times 2 pi times the radius. That's going to be our equation for lateral surface area of a cylinder. And then if we wanted the total surface area of a cylinder is going to be the lateral surface area, the height times the circumference of the circle, plus, now there are two bases. There are two bases, two circles. So the lateral surface area is going to be the height times 2 pi r, and 2 times the area of a circle is pi times the radius squared. That's the total surface area. And we can practice here. Here we have a right circular cylinder, and they want us to find the exact lateral surface area. That means leave pi in the answer. The lateral surface area is equal to the height times the circumference, which is equal to, here, our height is 12 inches, and the circumference is 2 pi times the radius, and our radius is 5 inches. So that's 12 times 10 pi, 120 pi. Area is inches squared. That's the surface area around this cylinder, not including the bases. Now, if we want the total area, for B, the total area is going to be the lateral surface area plus the area of the two bases, the area of the two circles. So that's going to equal 120 pi plus 2, and the area of a base is pi times the radius squared. So that's going to be 120 pi plus 2 times 25 pi. 120 pi plus 50 pi, and I can combine those like terms. That's going to be 170 pi inches squared, because area is always inches squared. So in many ways, cylinders and cones are easier than prisms and pyramids because you know your base is a circle and you know your equation for the area of a circle and the circumference of a circle. Whereas when you have polygons, you have different formula for the different polygon shape. All right, let's move on to the volume of a cylinder, the volume of a cylinder. Now, if you remember, the volume of a prism, which has two bases, is the area of the base times the height. So what equation are we going to use for the area of a base in a prism? Well, it depends on the shape. If it's a regular polygon, we need the area of the regular polygon. If it's a rectangle, we need base times height. If it's a triangle, we need 1/2 base times height. But for a cylinder, it's actually easier. The equation is still the area of the base times the height, but we know the base is a circle. Pi times the radius squared times the height. That's how you find the volume for a cylinder. So volume is still the area of the base times the height, but we know that the area of a circle is pi times the radius squared. Pi times the radius squared times the height. So as I said, it's sometimes easier to find cylinders and cones because you know that your base is a circle and you know what the equations are. Let me go ahead and get this out of there because I don't like having incorrect things on my forms there. There we go. So let's go ahead to this example. Here we have, Now here we're given diameter is 4. Don't be fooled. If they say the diameter is 4, that means the radius is 2. That's a very common trick in these types of problems to give you the diameter, and you're going to need the radius. So the diameter is 4. That means the radius is 2. And the height is 3.5 centimeters, and everything is in centimeters. And they want us to use the calculator to find the volume, which means we're going to use the pi button on our calculator. Volume is the area of the base times the height, which the area of a circle is pi times the radius squared times the height. So this is going to be pi times 2 squared times 3.5. So that's going to be 4 pi times 3.5. Put in the calculator, and to 2 decimal places, our volume is going to be approximately 43.98 centimeters cubed, because volume is a cubic unit. So this is just a reminder how closely prisms and cylinders look. Lateral surface area is height times perimeter, but for a cylinder it's height times circumference. The total surface area is still lateral surface area plus the area of the two bases. And the volume is still the area of the base times the height.